Can you see the slide deck? Is it full screen?
Yeah.
I can't see anyone, so
Yeah, we can see it. It's good.
Thanks.
Okay, perfect. Thank you. Yeah, so my name is Heidi Seibold. I am giving this webinar today on behalf of HDRUK, but usually I'm the co-executive director of the Digital Research Academy. I have a background in data science. I did my PhD somewhere between statistics, machine learning, and medicine. And for everything that we developed, we also developed code with it and software. So I'm very interested in the space of research software engineering and health research. And I know that most of you have like a background in statistics or data analysis. So I think I'll be probably a good person to talk from the perspective of a statistician on what's important in research software engineering and health research. I looked at the things that you submitted beforehand in terms of what in particular you'd like to see covered in this session, and I tried to cover as much as possible, but please do feel free to ask questions throughout, if possible through the chat, so that I can answer them whenever there's a good point in time to answer any questions. But one of the things that was brought up in the registration already was what is actually the difference in research software engineering and health research versus in other fields or in general. And I would say the topics that I covered today are pretty broadly applicable. So it's not only health research, it's generally research software engineering. A couple of the examples that I'll bring, or most of the examples that I bring, are from the health research space, so it connects better with you. But really, these good practices that I'll be talking about today are generally for research software engineering, if that makes sense. So why should you care about research software engineering? Well, you're here, so apparently you do care enough to come to the session. But in general, there are a few really good reasons, I would say, why we should care about good research software engineering or good coding practices in general. One of them is, and that's the slogan that was popularized by the Software Sustainability Institute in the UK, which says better software, better research. If the code that we write is not trustworthy and not reliable or not reproducible, then how good is the research that we're producing? So really, this is quite important to think about good software practices in terms of already when we think about writing code for data analysis, that if that is disorganized or low quality, then anything that we create and put out will be lower quality or less trustworthy, at least. So yeah, it's really an important building block for good outputs, good research. Another reason for thinking about good practices early on is that sometimes you have to hand over a project to someone else, and if it's disorganized or not well maintained, then it's very hard to hand projects over. So one example is actually my very first R package that I wrote as part of my bachelor thesis, where I created software that was supposed to detect areas in Germany with a high risk of unexploded bombs from the Second World War. And this is obviously, when I went into medical research, wasn't as much as a focus for me anymore. But this was an open source package. It was well maintained. There was good documentation. And so when someone else got interested in the topic and started doing a PhD on this, I asked them if they wanted to take it over and become the maintainer of this package, and that worked really well. So handing over is another reason why good practices make just so much sense. I did think it would be a good idea to ask some other people what they think, why having organized code, writing useful code, writing code together, or using automations, which are the 4 topics that we're going to talk about today, why they think that is important. And I got a few interesting replies from people. So for example, this one here complains that they had taken over a project from someone else, and it was not very well organized. There were no code comments. It was not documented well. So it took them a lot longer than really necessary to contribute really and improve the project, the code base that they were supposed to be working with. Another example here from Cohen is the example how automation can be really important. So Cohen speaks of the PhenoChem project and how every researcher had to set up the software on cameras. And so at some point, Cohen was fed up with all the problems and people coming to him for questions. And so he automated the whole process of installation. So this is an example where automation really helped improve the quality of the research. And then Steve here also responded with a nice story about how collaboration really can work in a code project, and how useful writing code together and working on code together can be. And he speaks of a collaboration that goes across continents, where they would get together, review pull requests, write tests for each other, and commiserate, which he wrote. So I think this is a nice example of how, collaboration and working together, even in like a space where we think like usually like, the coders, they're like on their own, but it's not really like that. Working together does have such great benefits, as we see here in this example. All right, I want to go see, I have to organize my screen a little bit different so that I can actually see if you send me any questions. All right, I want to see if there's already any questions in the chat. At the moment, there's none, but please feel free to send any questions to the chat that might come to you throughout this webinar today. All right, so then let's dive in, because now I told you why you should care. And you probably wanna now get started. So I brought a couple of suggestions on how to get started, but it's what is really important to me that any of them, if you pick one of them, it's already so much better than doing none of them, right? So you don't have to be perfect all at once. Pick the thing that's easiest for you or your team, or that sounds the most interesting to you. Don't feel like you have to be perfect right away. So the 4 suggestions that I'm bringing to the plate today is number 1, get organized. Number 2, create useful code. Number 3, collaborate effectively. And then finally, use automation. So what do I mean by these 4 points? Number 1, get organized. If we have an office that's a complete mess and we're looking for a piece of paper, then we're going to have a very difficult time. The same holds true on our computers. So if we don't know where things are, if we don't have our files and folders organized, or if we don't have good names for things like files and folders, then we're going to have a very difficult time. On flipping that around, using good names, organizing things well, will have a tremendous impact and help us a lot in writing good code, because then we can actually find the code snippets that we're working on at the moment. Adding code comments also is part of being organized. Generally, documentation, of course. Formatting your code so that others can read it too. That's a point that I used to undervalue, I'm not gonna lie, but if you have it nicely formatted in a way that's more easily readable for humans, that can help a lot. And then finally, I want to mention version control at this point, because that's something that helped me do all the things above a little bit better anyhow, especially the organizing the files and folders, because when you're using a version control system like Git, well, you're gonna be just a little bit more forced to think about your folder structure and the names of things, yeah, just as part of the process. So if you don't know what version control is, version control helps you keep track of the different versions of your code or other text files in a way that is very, yeah, strict in a way, and also delivers backup as part of the workflow as well. All right, just a quick example of why good organization makes total sense. My very first research project that I did when I was a master's student was a complex statistical model for gene expression data. And we did like simulation studies, and all the models got very big, and it was big data sets. And I had to go through several attempts of actually computing the whole thing, because I first tried it on the desktop machine at the institute, but that didn't end up working because it just got too big and my computer crashed. And then I went to the institute's cluster, and turned out the same thing happened there. So the IT guy was like, Heidi, you have to go to the high performance computing cluster and stop crashing our institute's cluster. So I went there, and there it finally ended up working. But the problem was, for every new system at the time, I had to change the code a little bit. So of all the code that I had various copies that are very, very similar. It was very hard to keep track of things, and it ended up in a complete mess. And I talked to a more senior researcher at the Institute about this problem, because I was worried about reproducibility and of what I should share with other researchers. And they were just like, oh, don't worry about it. We all have a little bit of a mess on our computer. And I felt like that was so wrong. And that's how I got into this whole thinking about reproducible research and how to improve my organizational skills in order to adhere to good coding practices. These are very simple things, right, that we can do. But when we start thinking about naming, for example, we want to use names that mean something, not my abstract, but have the date of when we gave the talk and what conference we gave the talk at. Instead of using a file name with spaces and punctuation that's hard for computers to read, let's use dashes or underscores instead, because computers are much more happy with that. Let's be consistent. Instead of saying figure 1 and fig 2, have consistent names across figures of the same project. And finally, just don't do whatever the last example here is. So what are good rules for good names? Number 1, make it machine readable. Number 2, make it human readable. These are the most key rules of file naming. But then what I encourage you to do is to think about consistency. So yeah, in the figure example here, fig 01, and then write about what the figure shows, for example, and decide when to use underscores and when to use dashes. And finally, sometimes it makes sense to use file names that play well with default ordering. This slide deck, for example, that I'm showing right now, starts with the year and the month that I'm giving the talk in. And when I look at all my slide decks that I use for talks, then I can automatically have them ordered according to when I actually gave the talk, which is very useful in that case. All right, that's topic number one. Let's look at topic number two, creating useful code. What are the things that I want to talk about when it comes to creating useful code? Yeah, number one, it's useful to others when they have access to it. If they don't have access to it, it's obviously not useful. So make it available to the people that need access to it, right? That can be a close collaborator, could be via sharing Git repository together. It doesn't even need to be public if it's just a close collaborator, right? But if you want to share it with the world, then a public repository would probably make more sense. If you take it a step further and really think about software, then having the software available somewhere where people would look for it, an R package, the go-to place is usually CRAN or depending on what type of package, bioconductor. But think about how you want to make it available and to whom. Generally, when creating code, think about the user. So think about what knowledge do they have, what knowledge do they need. That goes in line with writing documentation, of course. If you write the best software in the world, but there's no examples of how to use it anywhere, then it will probably not be used as much as it could be. And finally, using a license is generally very helpful in making code useful, in the sense that other people know what they're allowed to do with the code and what not, right? If you don't put any license with your code, then people generally aren't allowed to do anything else than look at it. If you want people to be able to reuse it, then you should use a license for that. There's a very nice website that helps you picking a license for your code. It's called chooselicense.com. It's very easy to remember, chooselicense.com. Yeah, so let's talk about an example. That's my R package called Model for You. It's an R package for stratified and personalized treatment effect estimation. I developed that as part of my PhD. And the special thing about the package is that it doesn't implement anything new, actually. There's an R package that can do everything that's shown in this package, but it's a lot more broad. So what we wanted to do with this package, Model for You, was to make it a lot more user-friendly for the people who wanted to do specifically stratified or personalized treatment effect estimation, right? So who wanted to find out which types of patients benefit more from the treatment or which types of patients benefit less from the treatment. I can share some good things and less good things about the package also in terms of creating useful code and making it useful for other people. I think what's good is that it's a simple package that's simple to use, that builds on the work of others. It's user-friendly for a very specific use case, and people who have that use case will find it useful, I think. It has lots of documentation with examples of how to use it and how to apply it and how to understand it. And it uses a GPL license, which means you can reuse the software. There's a couple of downsides to it as well that I don't want to hide. Honestly, I don't work in the space anymore, so I lost a little bit of interest in developing the project further after my PhD. So at the moment, there's no improvements of the package, no continued developments. I do still fix bugs if there's anything that comes up, or if there's anything that I need to do to keep the package on CRAN, that I will do. But otherwise, I'm focusing on training now. So here we go. Yeah, these things are sometimes in conflict, and but again, as with my other package, if someone else comes along who wants to become the maintainer and take it over, if you're interested, get in touch. I'm happy to hand it over to someone else. All right. Next topic, and that was also something that in the registration form someone asked about, like, can you tell us a little bit more about how to work together, how people can write code together? And of course, I want to do that as well. So this topic now is about collaborating effectively. So number one is, again, mentioning Git, because I think it's a very, very useful tool for collaboration. It helps you create a workflow so that several people can contribute code to the same project without getting into huge trouble. You still have to think about, like, whose code, if there's two people working on the same line of code, you still need to think about, like, whose code are we going to use in the end. But I mean, that's pretty obvious. But generally, working with Git helps me with collaborating with other people so much. Obviously, other version control systems are similarly good, I would say. I would just say currently Git is the most used, and a lot of people know it and know how to work with it. Second, I want to mention again that describing your work in a way that others can actually contribute is a really, really important building block to this. So imagine you're coming into a code project, and that might just be a data analysis, or it might be a whole software project. It really doesn't matter. But you come as a new person into a project, and all you can do is look at the things, but there's no guide on how to get started, how to contribute, where to find things that, people want contributions to, then it's going to be a lot harder than if there's like a contributing guide or a clear workflow of how to get involved. Part of that is using issues, so or similar things like other people use Trello or task boards, where it's clearly written down what are things that need to be done. And bigger code projects often use issues, and then also mark issues with the tag good first issue if they think this would be a good first contribution for someone new coming in. So having like a contributing guide as well as the tags with issues can be really, really useful. So I want to give an example of how this could look like from a project that's not quite a code project, but I think a project that showcases really well of how to make contributing really nice and fun and easy. And that's the Turing Way. The Turing Way is an online book for reproducible, ethical, and collaborative data science. If you haven't heard of it yet, it's really cool. Check it out. It also comes with a wonderful community behind it. So I'm a big fan and contributor. The Turing Way has a very nice README that's even available in various languages, and that describes some things about the project, how to get in touch with people, how to use issues, and how to collaborate. They also have a specific guide on how to contribute to the Turing Way, and you see that they make it very friendly, very down to earth. They use emojis and have various kinds of things of how to contribute, inclusivity, getting in touch, how to actually write chapters of the book, and so on. And again, as I said before, they also use issues with issue labels that showcase, like, this would be an issue for someone new coming in, for example. This is an example of an issue. Again, this is not very, not an issue for new code, but it showcases, I think, really well in a quickly understandable way of how issues can be used. So this is an issue that was opened by Danny, starting a discussion on maybe we should use more open infrastructure for the Turing Way project, saying, for example, moving from Twitter to Mastodon, and other tools as well. And so the issue is essentially, you can view it a little bit like a forum where people have discussions. So another person comes in and pitches some ideas. I also said, hey, instead of Eventbrite, we could show how Indigo could be used for managing events, which is an open source software. So this is just like an example of how the discussion could go. The content of the issues is not as important, but just so you can see how these conversations can work. Yes. Again, if you have any questions, put them in the chat. I currently see no questions, so I'll jump into the final topic that I wanted to share with you, and that is automation. I want to talk a little bit about the topic of reproducible pipelines. So the idea here is that you have data coming in and you want to do data analysis, and first you need to clean the data, then you need to analyze the data, then you need to write a report, and putting all of these pipes of the data analysis pipeline together in a way that if one of the data sets changes, it still can be run again without too much additional hassle, is something that to me always felt really important, because this always happens. I've never had a project where I wrote the code once and did the analysis once and nothing in the beginning ever changed, right? So creating these reproducible pipelines where things fit together and you basically change a thing somewhere and rerun it and it still works and creates the output that you want. That's something that I always found really important, and especially in the case of data analysis. Another topic that I wanted to mention is the topic of automated tests. So that's particularly useful when writing software, but also actually when doing data analysis. So automated tests means that you create tests that say, hey, if this comes in and this comes in, this needs to be the output. And then every time you run the code or change something in the software, then the test checks if this is still true and warns you if it isn't. And then that is particularly useful for software that becomes very, very complex. And then sometimes you change something on one end of the software and it has an impact that you didn't anticipate at another end of the software. And if you have tests, then hopefully you've set up your tests in a way that you catch that, right? So that nothing breaks just because you changed one line of code somewhere else. And then finally, CI/CD is something that I find really helpful in cases where you want to, well, on one hand, create automated tests that run every time that you push something to your Git repository, or in cases where you want to publish something every time you push something to your Git repository. So CI/CD is essentially an automation that runs on top of, for example, a Git repository. And for example, we use it for our websites, right? So when I change something in the website text and I push to a repository, then the CI/CD automatically regenerates and publishes the website every time we change something in the code. And obviously, for almost all of the things, I mentioned Git somewhere in what I talked about. So again, Git is very important for good coding practices. All right, let me share a couple of examples. So I mentioned this idea of reproducible pipelines. I am a big fan of combining text and code in the same document, which is called literate programming. An example of that is R Markdown or Quarto. You might have heard of those. I personally, for my papers, I used a combination of LaTeX and R, which is called knitr. And here in this example, you see on the left-hand side is like the raw version, and the green bits are the code chunks, and the gray bits is the text. And on the right-hand side, you see the rendered version that would then also show up in the PDF. And you see that the text is the same. And then you see the code, but also the output of the code as well. You can change the settings in the code chunk so that you don't see the code, or even that, for example, this table shows up as a properly formatted table as you want it in a paper. This paper here in particular that I'm showcasing showcases the package model for you, which is why we wanted to actually show the code that's run, so that it depends a little bit on the use case that you have. But yeah, so in this case, this helps me to create or come closer to the idea of this this pipeline that I talked about before, because I can now, if I have a setup like this, I can see the paper or the report or whatever you need to output as part of my pipeline, right? Because then I can automate that together. Another tool that helps me do that and create that pipeline is called Make. Make is a pretty old software actually, but I think it's going to be around for a while longer because it's just so useful and works on so many different systems. So the idea of Make is that you are able to clearly specify what the target is that you want to generate. So here in this example, it's a PDF file, so that could be a report or paper. And what are the files that this target depends upon? And every time one of the files that the target depends upon changes, Make will make it easy for you to regenerate the target. And how does it do that? It needs something that it needs to run from you. And so in this case, it's a command that could also be run in Bash that generates the PDF file from the text file. So it needs this command. So just to show you an example of how this works, same paper as before, the model for you paper. Here, what I want to generate in the end is the PDF file with the manuscript. But here in this example, you see that there's 3 yellow bits, right? So 3 targets that I want to generate. How does this work? So all is like a catch-all in Make that says like if you run in the end the command make all, then it makes everything that's here in green. In our case, this is just one PDF. So this is the final output that we want to generate. How does Make know how to generate that? We go to the other target. This is the same name, right? So now we know that this depends on a text file and a bib file. So the bib file is the bibliography of the paper. And then here in orange, we see the commands that we need to run in order to generate that PDF file. But that PDF file depends on a text file that in and of itself depends on another file, right? So this is a knitr file, which I showed you before. And to generate the text file, we need to render the knitr file to a text file first. So in essence, we now have like a chain of how things belong together, right? So we know that the knitr file is the needed for creating the text file. The text file is needed for creating the PDF, and the PDF is the thing that we want in the end. And so this simple text file here, this make file, shows us very clearly how things belong together and how the pipeline that I showed you before needs to stick together. All right, so I gave you a list of things today of how to get started with good research software engineering practices. And you might have noticed that some of them are really basic, like organizing your files and folders and giving good names to them. But this is really the basis of good practices in coding. And if you get those right, then everything else is going to be so much easier. I'm happy to answer any questions. So if anything came up, please put them in the chat already, and I'll share a little bit more and try to answer your questions in just a minute. Before we finish up the session and move to the questions, though, I want to also mention that there's a little bit of a, I would say political or social part in this whole thing, especially when we think about research communities, but I've seen this elsewhere as well, that often the code is not the priority, but a means to an end. So in research, in particular, the end goal is always to publish the paper. And if we really want to have good research or have good data analysis in other contexts, we really need to think about the code and give people the space to actually think about the code. Because otherwise the people who care about code and want to do the right thing are going to go elsewhere. And so researchers and other people who work with data and code need time to write good code. And that's something that I also want to mention in this context, because it is hard work, and getting things organized and set up in a nice way that is reproducible and reusable it just takes time. It just takes time. If there's one single thing only that you take away from the session today, I think if you don't do it yet, start using Git. I think that's a great way of getting started with good coding practices, because it pushes you to do a couple of things that we talked about today well from the get-go. I shared a lot of ideas and tips and little tidbits along the way today, but if Git is the only thing that you take away from today, take that. And everything else, the slides will be shared with you. You can always go back later and look at, oh, what else can I do as well? Yes, before we finish up, I want to hand over to Rosie, who can talk a little bit about what else you can do in the context of HDRUK and research software engineering.
Thank you, Heidi. That was great. So if you are interested in learning more about research software engineering in this space, then we have some other resources that we can point you to. So firstly, we have a self-directed online course on our Health Data Research Futures platform, which is our free online learning platform. So on there, you can find a training course all about research software engineering. You will recognize Heidi as she features throughout that course. I'll just pop a link to that in the chat. So that's something that you can kind of do in your own time to refresh on what you learned today, and also take a deeper dive into some of the topics that Heidi's covered. And then if you want to go even deeper, then there is a research software engineering workshop happening later in the year. If you'd like to be kept on the list to be notified when the dates are released for that, then just ping me a message in the chat now and I can make sure that you're added to our mailing list. So that is a more intensive online course running over a series of weeks. Usually it's for an hour every Tuesday afternoon, and that's in a small cohort of about 20, where you'll be given assignments from our tutors and links in with the bite-sized video learning pathway on futures. So it's an opportunity to get that instructor-led kind of synchronous training in research software engineering. So that's coming soon. Could you ping to the next slide, please? I think I've got some more. Yeah, so we've got some more training on offer from the HDRUK training team. I would probably draw your attention to our Distributed Computing for Health Data Research workshop, which is happening in May. So that is an opportunity to get hands-on training using some big data tools. And we also have our applications are opening soon for our master's scholarships as well, which I know that will be circulated in one of your upcoming sort of AphA newsletters. So applications for that are opening quite soon too. So if you have any questions at all for me or about any of the training that I've just mentioned, or anything more broadly to do with health data science training and learning, then just get in touch with me. And I'll be happy to help. So thank you.
Thank you so much, Rosie. I want to open the space for any questions that you might have. Feel free to pop them either in the chat or we're a small group. Feel free to just unmute yourself and speak. Any advice with getting started with Git? Yes. So my main advice for those who are completely new to Git is to find a buddy or a learning environment where you can learn about Git together. So the RC workshop series, for example, that Rosie mentioned, that will run probably in the summer, will introduce you to Git and provide you with buddies to learn how to use it together. Because so the way I learned Git was all by myself, and it can be a little bit of a struggle the first time you learn it. To me, it definitely was quite a steep learning curve. It is so intuitive and logical once you get the hang of it, but getting started can be a little bit tricky. Oh yeah, Rosie also pasted something in the chat that might help you with it. So I think that's my advice with getting started with Git. There are also a lot of online tutorials if you're really good with learning by yourself. Just search for Git tutorial, and if you're, for example, an R user, search for Git tutorial for R users, because that can be useful to make it specific to the tools that you already have, because you can use, for example, Git from RStudio or Visual Studio Code or whatever tool you use. So that might be useful to incorporate. Does that answer the question? All right. Any other questions? Any other thoughts?
Looks like there's one coming.
All right, I don't see anything yet. Well, anyway, if you have any any further question afterwards, you can also message me, or I'll pop my email address in the chat.
Perfect, yeah. And just to let people know that the information about the scholarship and some of the upcoming stuff that's been mentioned will be in the magazine as well. So if you don't catch it here or save the links, that will be available to you again when that comes out. Oh, there might be something from Chris.
Perfect, Chris. That sounds great.
Nice.
All right.
Cool.
If there's no other questions, yeah.
Yeah, perfect. Thank you very much, Heidi, for joining us. It was very informative. And if I get any questions or anything, I'll pass them on to you. But
Well,
thank you very much for joining us.
thank
Well,
you.
Thank you.